I'd like to introduce our second speaker today, Dr. Agenor Mafra Neto, and he is a chemical ecology researcher and entrepreneur in the entomological field of insect chemical ecology. He's the CEO of ISCA Technologies, a company specializing in the development of semiochemical solutions for pest management, robotic smart traps, and nanosensors, which sounds pretty exciting. So I'm excited to see your presentation, which I know is going to sort of take us in different directions and looking at big scale and small scale farming, maize farming and fall armyworm. So welcome to our workshop, and please start.
Thank you, Alison. Really a pleasure to be here today. What is the role of biological control in IPM? And I'm going to talk a little bit about our experience in Brazil and a little bit also in India. So we have been working with fall armyworm for quite some time, and there are 6 major components to an IPM program that needs to be done everywhere we go. First is that to have a good identification of the pest. The other one is to be able to monitor and assess pest numbers and damage, but also the natural enemies that you have in the field. The third one is to have guidelines of when the management action is needed. So you can use preventative pests, you can prevent pest problems, like avoid economic damage. And you should be using a combination of tools with different modes of actions, like biopesticides, biological control, cultural, physical, mechanical, and chemical management tools. And once you take the action, you assess the effect of pest management. So it's really important in a program, an IPM program, any IPM program, to monitor either by scouting or using pheromone traps or any other form of monitoring. And pheromones and semiochemicals can help in the pheromone trap side of things. So biocontrol and biopesticides. Biocontrol is the method of controlling pests using other organisms. It relies in predation, parasitism, and other natural mechanisms. Biopesticides are pesticides derived from natural materials such as animals, plant, bacteria, and other minerals. And so there are 3 categories of biochemical pesticides. Biochemical pesticides, for example, pheromones and canola oil, baking soda, etc. Microbial biopesticides and plant incorporated protectants like GM crops that contain Bt genes and express the Bt genes. So conventional control. Conventional control works by the grower taking the insecticides and chasing the pest with that insecticide. So it's really important that you have extremely good coverage on the in the field, that you cover every single part of the plant that you are trying to protect. The biggest problem with that is that it kills everything. It kills all the natural enemies, kills sometimes the pest. But one of the biggest problems is that we have been losing a lot of modes of action because insecticides drive the evolution of resistance. And the evolution of the resistance is very simple. You have some individuals in the population that are resistant. If you spray the same mode of action over and over and over, you then end up selecting for the resistant pest in the field, and you end up with a pest that is resilient to the application of that type of insecticide. The IRAC has 37 modes of action, including insecticides and different types of conventional insecticides, viruses, bacteria, etc. But what is really bothering me is that the Asian countries seem to, according to a report that I saw by this group, has only 7 chemicals belonging to 5 modes of action. So this seems to be a very, very small number of modes of action. And so it's really, really important that we have either a very, very strong integrated resistance management, or we bring more modes of action, or both. So we usually work with a different concept. Instead of taking the insecticide to the pest, we bring the pest to the control method. How do we do this? We usually focus on the mobile part of the population of the species, and usually we address the adults. The growers, usually they are worried about the larvae. So, but the idea is that if you kill one adult, for example, of fall armyworm, you're killing about 500 to 2,000 larvae, future larvae in the field. So how we do this pest control method, what we modify the behavior of the bug to come to the point source. We use sex pheromones for mating disruption, where males cannot find females, and we use attract and kill, where we use an attractant, the insect comes and manipulates the plant, the point source, and dies. I'm going to tell you a little bit about our experience in Brazil. Brazil, we have many different clients, but I want to talk specifically about the very large stakeholders in Brazil. We are working with groups that have between 400 to 600,000 hectares of crop production a year. And these people are producing, this is basically how they harvest and how they plant the new crop. They are harvesting the old crop, planting the new crop. So you have crop all over the year in this region here of Brazil. For fall armyworm, that's a huge problem, because fall armyworm has host all year round. So from January to December, there's host in the field. So you have populations that that are always growing, and they become more and more difficult to control using conventional methods, and they are becoming resistant to many modes of action, including genetically modified plants. But the problem of Brazil is that you don't have only Spodoptera, you have several other different pests that are being used, that the grower is using insecticides in the field to control. So if you come with a solution, say mating disruption for Spodoptera, the grower still is going to use a lot of insecticide to control everything else in the field. So it's very important that you control a certain group, a certain cohort of pests. Otherwise, your product is not going to work for the grower in the field. They are going to continue to use conventional pesticides. So when we started working in Brazil in 2012, 2013, bringing new forms of protection for growers, for row crop growers. And during that interaction, I started working with the group of Bom Futuro. They grow more or less 600,000 hectares of different crops, basically soy, corn, and cotton. And after a couple of years, we started a center of excellence for semiochemical control for row crops. Together with Bom Futuro, both ISCA and Bom Futuro invest in this center, and that allowed us to bring products now that are being developed together with the farmer in a way that inserts the product inside the crop. These large growers, they want to go green. They want IPM with biopesticides, and biopesticides being biological or being semiochemical. So to control fall armyworm in Brazil, we found out that we cannot do only mating disruption. We have to do also attract and kill. We developed a formulation many years ago called Splat. We can apply by mechanically, and in Brazil we apply by airplane, tractor, drone, and you can also apply it by hand. Splat is a FAW, is a mating disruption for the fall armyworm. We apply this in the field, and this many dollops in the field compete with the females that are emitting pheromone, sex pheromone. Males cannot find the females, no mating. You end up, the population end up collapsing without a single drop of insecticide. That's the major advantage of mating disruption. The problem is that it's extremely specific, species specific, so it mating disruption for fall armyworm works only for fall armyworm. And then we have another product called Noctovi. It's an attract and kill for noctuid moths, especially including fall armyworm. So this product, you put point sources in the field. Both males and females, especially gravid females that are very hungry, they come, manipulate the point sources in the field, and they die. And usually what we do is we sell the product. The grower uses 1%, adds 1% of an insecticide, and that affects control in the field, and also lasts for significantly longer than an application of insecticide. We did the calculations, and for about 1,000 hectares, a grower using only conventional crop protection would use a tank load, truck load of insecticide. With our product, they use about 200 liters, which is about 1% of what you have in that truck. So the integration of semiochemical solutions for the fall armyworm in Brazil is being done with Splat fall armyworm and Noctovi. And here you can see the application, the attractor application of the formulation. It's very sparse. You don't need to cover the entire plant. We did, this is a field trial where we did Noctovi by itself, and then Noctovi with Splat FAW for mating disruption, and the attract and kill for Noctovi and mating disruption at different doses. And we also use always the grower's control method. You have to remember that these growers, they have access to every technology that exists for row crops in the globe. So it's they are working at the maximum. They extract as much as they can from these different techniques. So to go from, to show differences in yield in these crops is very difficult. Noctovi in Brazil, in these farms, is applied with motorcycles and airplanes and tractors. And we use monitoring traps that, water monitoring traps is a pheromone lure to monitor populations in the field. And here you can see that in that specific trial, in red, you have the control population dynamic. And then in the other colors, you have the Noctovi and Splat at V1, V2, V3, all the way to the end of the season. We also use the David scale to trigger applications of insecticides. So when you hit a percentage of damaged corn plants at the threshold of 20%, that triggers an application of insecticide. By using Noctovi and Splat FAW, we have been able to reduce the number of applications in comparison with the control that took 6. We were able to reduce to 3 applications only. But for the grower, reduction of insecticide sprays is great, is excellent, but for them, they need to look at yield and profit. So instead of us trying to figure out what is the yield, the grower actually harvested the yield, harvested the crop, and that allowed us to, are we still, am I still sharing or not?
Yes, you are. Okay,
good. And then check what is the, how much of the product we have in the crop. What was the, what does the yield in the crop? And as you can see, when you compare against the control, we got basically about 40% of larval reduction. We got 96% of trap shutdown, but this is the important part where the grower got about $92 extra profit at the end of the season. We did the same thing. Fall armyworm also attacks cotton and is extremely damaging to cotton because it goes into the flowers and the reproductive organs of the cotton plant. And when we do the same system to protect cotton, the grower ends up with a significantly high extra profit per hectare of about $1,000, which is more or less translates to more or less 5 extra bowls, 5 extra pods of fiber per linear meter of cotton. So all these things have been shown that semiochemical control works in the field. We see increased populations of parasitoids, of other microorganisms of control, natural enemies, and the system is working for these very large growers. What about small stakeholders? So we went to India together with our sister company, ATGC. And in India, the biggest concern that we had is that growers have very, very small plots. But the farms are a few acres large, so like 1 to 5 hectares. They have very high FAW infestation right now. And but the interesting thing is that in corn, FAW is the main pest. And that allowed us to go after products that can provide mating disruption. In India, we developed several different novel formulations for mating disruption, and we called them Cremit. There are 3 here. I'm going to show 3 forms of Cremit. One is a microencapsulated system with a type of organic glue that binds this microcapsules to the plant, so you end up with a very high longevity of these pheromone sources in the field, even though they can be sprayed with normal tractor and backpack sprayers. Here in these graphs, you can see in the bars, you can see the population damage or infestation that you have with a fall armyworm in the field. And when you look in this purple line here, you see the farmer's practice. So you can see that for most of the treatments that we have in this different in these different graphs, you can see that the grower has the highest populations and the highest damage in the field due to fall armyworm. The second one is the Cremit tablet, which is we infuse the pheromone into this nano porous matrices that are then put together, that are formed into pills. They drop that in the field, and the Cremit paste, which is very similar to the formulation that we have in Brazil. But in India, instead of selling this in very large containers, we have the grower using this in small toothpaste tubes. And this is the dollop that they have that they put in the field. Everything is done manually. And the Cremit SM, which is the microencapsulated system, we found out that we can do tank mixes with that. You can use the same tank that you're going to do an insecticide application, and the product works really well. Also works by itself, but it works really well with that. But I want to bring your attention to this. In Brazil, when we do our trials, we use a minimum of 30 hectares and as many as 300 hectares per plot. Here, we are using blocks of basically 5 acres, which is about 2 hectares. That's a very small plot, and I was very concerned that we wouldn't be able to get good control for this plot, in this plot. However, we went ahead, did the applications, and with the micro-encapsulated pheromone, we found out that it actually works. It works even better when you do tank mix with a few of the insecticides, soft insecticides that we had in India. And we can manage, with 2 applications, you can manage FAW for the entire season. And there was a reduction of 40 to 50% of the conventional insecticide applications that the grower used to control fall armyworm. Those little tablets, we look at the number of tablets that we put in the field from 1,000 to 2,000 against the control or farmer's practice. Again, small little areas. And again, the tablets work significantly better than using the growers' control. And the application is very simple. You just drop the pill in the middle, on the soil or into the world of the plant, and then you're done with the application. And you repeat that in the middle of the season at V4 or V5.
1 minute left.
Sounds good. We have the Cremet P for FAW, where this one we already harvested, and we have between 11 to 25% of increase in control. So our conclusions are basically that biocontrol and biopesticides are extremely, they work together. They allow us to reduce the reliance on conventional pesticides. They bring more new modes of action for an RAM program. They can control pests that are resistant to conventional pesticides, including GM crops, and they are an efficient way to control insect pests in small and large areas. They are easy to execute, and biopesticides and soft insecticides allow biological control agents to thrive. The things that I would like to see in a program like this is that the governments of this region, if there was a way to facilitate the registration of biopesticides and biocontrol agents. I would like to see if biopesticide and biocontrol agencies can be facilitated through the regulatory agencies. For example, EPA makes biopesticides much easier to register and takes less than a year, much less paperwork than conventional pesticides. I also would like to see the governments foster the registration of other insecticides with other modes of actions. We need to increase the modes of actions available for management of pests in the region, and promote safer, softer pesticides in the field. The other part, I think it was really well brought up by Mario, is to promote seasonship and get the seasons to demand for safer food and safer environment, promote area-wide IPM, the government promote area-wide IPM programs, and bring these pesticides, biopesticide and biocontrol agents to the growers by fostering entrepreneurial production of these biocontrol agents in co-ops, startups, the way that they are doing in Philippines. I think that's it. Thank you so much.
Thank you so much. And you have got questions. so hang in there. No, great presentation. I like the sort of reformulation of attracting the pest to the solution rather than the sort of pesticide to the pest. I really like that idea. You've got a few questions here, and starting with the first one, in attract and kill formulation, to kill insecticide is used. Is there a fear that insects can develop resistance to this insecticide over the years?
Yes, insects will always, if you don't control well if you don't have a good resistance management program, you're going to get resistant pests. So it's very, very important that you work with an insecticide that allows you to kill the insect. And there's a big advantage to our formulations, our attract and kill formulations, that we can, even though we are using 1% of the amount of insecticide that the grower would use per application, we are concentrating that in very, very small areas and into the formulation. So only the pest manipulates that. And in the case of Noctovi, the pest actually feeds on the formulation. So what happens is that these insects are getting a mega dose of the insecticide, dose that is much above than what would be needed to kill. And that delays tremendously the insecticide resistance. The other thing is that you can, the same way as you do with GM crops, where you can stack several different modes of action, you can do the same thing for this attract and kill systems. You can stack one or two different modes of action, and you can rotate them throughout the season, allowing you to avoid the development of resistance. But that's a very good question.
Yeah, good answer too. Here's a question. What actual active ingredients are in Splat and Noctivo?
So Splat FAW, the active ingredient is the sex pheromone of fall armyworm. And it's a product that we produce both chemically using synthetic chemistry in India, but also we are starting to produce that biologically, the pheromone, and reducing costs, allowing us to have very, very effective formulations at a very low cost. So biological, we produce that through fermentation or through plant breeding. Genetically modified plant breeding that produce the pheromone itself. And
Okay.
then for the for Splat, we use for Noctovi, we use plant volatiles that are attractive to the moth, but are not attracted to natural enemies like or pollinators like bees and ladybugs.
Okay, a couple. We'll just try and we've got quite a few questions, so we'll try and race through a few of them. Here's one. The paste method seems to be labor intensive and time consuming if you have to apply it one by one instead of just spraying it. Did you compare the cost of application for the products you mentioned versus the conventional method?
Yes, for that's one of the reasons why in Brazil we do everything mechanically. By airplane, especially because of the cost of this product. So you have to remember, with these products, you don't need to cover the entire crop. So you can, with one pass of the airplane for Noctovi per hectare, you control the entire field. Whereas if you're using conventional pesticides, you would have to pass 4 times. So we are using much less material in the field. So it's easier. So sometimes even manual application can be viable because the product lasts significantly longer than an insecticide application. In the case of Splat FAW, it lasts about 45 days in the field.
Okay. Here's an interesting question. I haven't seen this one before. Very interesting presentation. Thank you. Said the person. Could it be possible that the moth changes their sex pheromones as an adaptation to mating disruption?
It's possible, and that this process is called speciation. When a moth changes its sex pheromone, they have a completely different breeding system, and they become a different species. So it could happen, and all we need to do is to change the pheromone. But it's a process that in nature takes thousands of years. So we would have enough time to react.
True. We probably won't be around to see that, you and I, anyway. But are both
definitely
products,
not me.
are both products, Splat and Noctovi, are they required to be used together, or can we just use one of them?
We can use one, and that was what we showed in India. we can use just mating disruption when the key population, the key pest, is the pest that you're targeting. If you have a mix of pests, then you need to use Noctovi, or you need to use a mix.
Okay. Okay, one last question, and then we're going to move on to our next speaker. But here's a question here. Many species of parasitoids eavesdrop on the sex pheromone of their respective pest and uses these volatiles to locate the pest. How can we be sure that the OCs will not attract the wasps, although it does not attract ladybugs and pollinators?
We have many years of this has been answered by academia, where they have shown that some parasitoids they track the pheromone, but are usually in the field we don't see that problem. We also, especially because there's a lot of space between these areas, between the applications, and so you end up seeing significantly more biological control in areas where you apply pheromones than in the areas that you use conventional control. It's possible that you might hit some of the species of parasitoids, but so far we haven't seen pollinators or other biocontrol agents dying, going for this or getting disrupted by this.
Okay, and one last question. What if the moths fly into the field and are already mated? Will the pheromone still have an effect?
The pheromone has no effect to mated females. And that's one of the biggest concerns that I had in India, where the areas were so small. So you have all these borders where the moth can enter. So if you, but nevertheless, it was really cool because we were able to see that the product actually worked there. So most of the females that are in the field, they are being originated in the field.
Okay.
Thank you so much.
Excellent. No, thank you very much. And I'm just multitasking at the moment and flicking through for our last presentation. But thank you very much for that presentation. Very interesting. And there's lots of questions waiting for you there to answer.
Wonderful.
I know it very interesting. And I'm sure when you answer them, those answers will pop up for the rest of the audience. So it's really important if you've got the time to have a look at that. And I really like the idea of something you mentioned at the start around thinking about how farmers are also managing other pests at the same time. So ensuring that you're not just thinking of one solution for them, but thinking about how they may manage that as part of an integrated pest management approach. So thank you so much. Really good presentation. Thank you.
Thank you, Alison.
Excellent. So